whose equation is x minus y being equal to 0. So everybody, listen to my choice of words. I have to say some words instead of looking at my picture. I only want you to look at this object in the first octant, in between this red plane and the xz coordinate plane. Does that make sense? So technically speaking, the image I'm really looking at kind of looks like this. It's just that one widget of the section. Is everything inside there?
X minus y is equal to 0. Is that just a...
Well, I think as a line in the xy coordinate plane, this is no z values given. It's straight up. So it really is an equation. So if everybody understands what I'm looking at in three-dimensional space, let's put in the details. I think cylindrical coordinates is a great candidate of choice of technique, only because you see a cylinder there. So I think in the integrand position, I have, I said in the integrand position, I have
Just dr.
tangent of theta times r dz dr d theta.
Oh, is that dv?
Linda?
Oh, I thought that said dr there.
No, it's a dv. Sorry, I'm
That's
integrating with
confused.
respect to volume. You know, r is v square root symbols. It doesn't matter, does it?
No, I just wanted procedural things.
So you guys, let's talk. What do you think we could say about the z values? If I drew a nifty little green arrow, parallel to the z-axis within this particular object in free space, what are the smallest z values in those arrows' initial points? They're all going to be 0. And I think the upper z value is going to be. We'll see it again. 8 minus 1. Oh, but shoot, we can't use x and y. We have to use cylindrical coordinates. So instead of x minus y, we'll put x for 8 minus y, we'll put 8 minus r sine of theta. Now, how do the r values range? If you jump down to the xy coordinate plane, project this whole image into the xy coordinate plane, look at this particular portion of my disk. Within that disk, the r values range from 0 to 2. I agree. What about the theta values? This is getting me nervous because I'm not doing a good job drawing. But if it's just on this side of that plane, but off to the right-hand side of the xz coordinate plane, how are my theta values changing? 0 to 5 quarters. I agree. Does anybody else agree?
So in this case, y equals x, we got a pretty easy conversion.
Yes, I do.
Okay. So how would you do it if, say, it was some other equation?
You know, I gotta confess, you guys, if what's the integrand position is not easily accommodated with the same course, how would you do it? I just want that. Shoot, you guys, I really blew it, didn't I? I didn't remember saying that. I wanted to give you more examples of triple intervals. No, it's just scratch work at home and I can make up examples.
Okay.
Sure, I'll be glad to.
This is what you do in your spare time, just vent it.
Oh, yes, absolutely. You know, a lot of times I'll just make up a lot of examples, but I'll use it for exams. You guys, I'm only stalling because I'm going to be limited with my time.
You really are limited with your time. You got 20 minutes and a quiz to get. how long would you make this class every day, like? If it was
2
your,
hours is fine. I can answer homework questions and still good.
was this 3 days a week, 2 hours a day?
2 hours.
Okay.
Do you usually have a 3 day a week class?
She's asking, is this class usually 3 days a week? No, that you teach. Oh, that you teach, yeah.
Quiet.
No, I just don't like it. I can't stand teaching this 3-day week business, only because of exams. I don't like writing exams so short. That's the only reason why I don't like it. You know, we did at times have 3-hour classes. DE, we typically taught 3 hours a time, 2 days a week.
Oh, that would be nice.
Bump it up, on credit.
Actually, it's already 16 minutes.
Yeah, 36.
No, it's not this time.
I've already went to the college, I've already upped this to 3 months.
This
It's
is 4
just that,
units.
I meant 5 minutes. It's just the department needs to agree with that. And they have to.
Does that mean we get?
So you're telling- yeah, yeah.
Transcript?
What's that?
Does that mean we get 5 units on a transcript and not 4?
Yes.
Really?
Really?
But it
For this
hasn't
class?
passed the math department. What happened is that another colleague and I, we built a lot of labs for this course, for all of the competency sequence. And that would be a 5-minute course. But can't do it alone. You guys, can we just have one more example? Both with triple integrals, the way we were talking last time, and with cylindrical coordinates. So let's just draw the pretty picture. The first surface looks like a, gosh, you guys are killing me. Inverted paraboloid. Ay, ay, ay. So just like my ice cream cone. So here's my x-axis, here's my y-axis, here's my z-axis, and I have got something that looks like this.
Upside down bowl.
You're killing me. And I think y equals 4x looks like a... What
It's like super sharp, like that.
the plane looks sharp?
It's very nice, it's complimentary. Y, it's like 4, Z.
Yeah, all that means is
Got
that,
it.
yeah.
So he's saying, let's take a peek at the line y equals 4x, which is steep, and the plane's gonna go vertically up. Oh, but shoot, I guess when it slices into this paraboloid, it kinda looks like this. And now, I didn't put it on the inkboard, but now let's look at the volume of what's behind that particular plane, and in front of the YZ coordinate plane. So in the end, yes,
We already did this example last.
did we really?
It looks familiar.
We did one similar to it. Oh,
It
no, we
looks similar.
totally did.
It's okay, let's cheat, let's create this integral, and then we'll convert it to cylindrical coordinates.
We haven't done that part yet.
But you guys, again, my picture's a little unclear. Can I redraw that? How does it like this? Hold on. That's linear. And I think I am coming down on this angle. I think I look something like this. Do you guys agree?
It's more like called the bun cake.
It's a bun cake, I remember that, yes. My memory's so poor. So I think, if I'm gonna compute this volume with a triple integral, what's in the integrand's position is merely a 1. But if I were to integrate with respect to z first, and then y, and then x, well, you guys, aren't the z values merely changing from, well, 0 to 1 minus x squared minus y squared? I think my y values are going to range from 0. I disagree. Because I think the region with my green pen and the xy coordinate plane, over which I'm integrating, is really right here.
How do you know which side of the...
You don't, I had to explain it in English. I said, now let's look at the portion of this three-dimensional object that's behind that plane, but in front of the,
How do you know
Why is
from
it-
our two equations which side we're on? What we needed to integrate? From this, how do we know which side we're on?
you don't. That's why I
Oh,
said
you
in
don't.
English, I had to say, in addition to this,
Okay. and
look at
then-
what's behind that plane, but in
And
front of
then,
the y.
to the y-axis or whatever, you have to give another constraint.
Yeah, I do. It just
Yes.
wasn't described nicely with mathematical
Okay.
symbols. So I just said it in English.
Last time you said bound by the YZ plane.
Oh, did I? Bounded by the YZ plane as well as the plane y equals 4x.
Right.
Something like that. But you guys check this out. to come up with bounds of integration for y, look at this region, the SY coordinate plane. I've already taken care of the Z business. Let's just jump down to the SY coordinate plane. And look at my green arrows that are going parallel to the y-axis. Where does the tip of the arrow begin? On the line, y equals 4x. Where does the tip of the arrow end? No matter where the arrow is. On that circle whose equation is? Okay, so Madeline, you're saying root 1 minus x squared. I just came here. And by the way, the x values are just ranged from 0 to 1. Do you guys agree? See, I don't agree. I think that's wrong. What's wrong with the bounds? It doesn't go that far. I think the x values, this green region, range from 0 to, well, whatever the x coordinate point of intersection is. Oh, shoot, you guys, I don't know what it is. I gotta take a break. To find out what the x values of point of intersection is, just realize the xy coordinate plane is merely the intersection between this line and this circle. It's just a system of two equations and two unknowns. Piece of cake. I'll make a substitution. I'll refer to y as 4x. I'll isolate x. Well, you guys, technically speaking, I really did make another mistake. I really should have plus or minus square root of that number, algebraically speaking. It's just that I'm dealing with a point in the first quadrant in the SY coordinate plane, so I just don't care.
Now we're gonna convert it to cylindrical stuff?
And now we're going to convert to cylindrical. Oh, actually, we can't. I got to put this in. Instead of 1 over root 17. Oh, I really like this question for cylindrical. This is nice.
Does it mean it's gonna be a test question?
It's a lot nicer to do the x first and then do y. Yeah. You get a lot nicer. Because then you're just going from 0 to 4x.
You know, I agree with that. I don't know if you guys caught that. You can hear Andrew. He's saying it might even be easier to integrate with respect to x first and then y. It just cleans up my bounds a little bit nicer. I agree.
Can you, like, on the test, like, are you gonna, like, hide in there, like, a partial fraction decomposition that we're gonna have to do? Like, one of those fun things for Math 31?
When I build really nice examples like that, the downside to it is that I probably would only have an expression here in terms of one variable. Because in multiple variables, then, when I actually anti-differentiate, I get more and more complex expressions. So typically I'll cheat, if I can do that, and in the integrand's position have something like 1 over x squared minus x minus 6, not involving z's and y's, just to make life easier. So you guys, let's translate. I think in terms of polar coordinates, I've got a triple integral. In the integrand's position, I have r. Did I say polar? I meant cylindrical. Okay. They really are the same thing. Cosine, excuse me, r times dz dr d theta. And I think my bounds range from 0 to, okay, I'll slow down. Look at the upper bound of integration for z. Using cylindrical coordinates or polar coordinates, isn't that just 1 minus r squared? I think my extreme values for r are going to be really straightforward, no tricks. Don't they merely range from 0 to 1? The only thing I have to worry about now are what my theta values are. So how are my theta values going to range? All right, something to pi over 2. But that's my question. So when I was looking at this morning, I'm thinking, wow, the theta values are really split. What's the lower bound of
We have
integration?
the line y equals 4x, which is, we define, what, y over x equals tangent theta?
Perfectly put. And y over x in this case is going to be, y over x is going to be 4. And that's so for solving for theta, doesn't that really give you the inverse tangent of 4? Would you guys agree? That was pretty slick. I don't know if you guys noticed it, but technically speaking, what I'm really doing is I give you examples where I give you the integral already, but I'm also giving examples where I give you the visual image of what the thing looks like in higher dimensional space, and you build the interval from scratch. I need you guys to get practical with both of those. So can I set you guys off and do just that?
What is it, building a roll from scratch?
I'm just saying, I want you guys to be able to evaluate these intervals when they're given to you, but I want you also to be able to create these intervals out of thin air if I give you equations and or pictures. To me, that's a big deal. Can I slow down on the homework and not post it yet? Can I just give you guys a quiz and I'll write it on the board? Just make sure you write it down.
I always forget when you do that.
Do you really?
Yeah.